We'll get Graham in here in a minute. There's a couple of things I just wanted to bring up that I thought would be interesting. First one is in the latest issue of the Heart of the Beast. I assume you guys are all ZR-1 registry members. There's a great discussion in here about redoing the FIA 24-hour run.
Yeah.
And I don't know how serious that is. Pretty serious. Okay. Guess if you want to run 215 miles an hour, it gets pretty serious. You know, we ran about 182 as a running speed in order to average the 175 for the 24 hours, and doing that at Fort Stockton. I did not get to Fort Stockton. I was back in Detroit while all this was going on. And, there is no guardrail at Fort Stockton. It's just a rectangular loop, and if you go off the road, all you do is you get out in amongst giant boulders, so you don't want to get off the road. And the ultimate danger is if you go off the road at night, you're going to be hard to find. But we were actually without serious incident in the Corvette run. There was a press guy from Car and Driver who was killed there a few years later when he ran off the road, not driving a Corvette. And I don't know exactly what the circumstances were, but it is well, anything at those kind of speeds is a dangerous activity, as is racing. And you want to prepare for that eventuality. So if we're going to go 215, you need to find a venue to do that. And Nardo is the only one I'm aware of that has the capability of being able to run those kind of speeds anymore. And it's, you know, I don't know how available that facility is. The W16 or whatever it was, Audi engined race car that took our record, took it by a significant amount, and then you got to go above that again to get in the record book. So if a group is serious enough about doing it, you got to put some money together to make it happen, and it certainly at that point it becomes doable. The other thing I wanted to bring up before we get Graham here, I don't know where he is. He knows he's supposed to be here. Pratt Miller has produced a 10th anniversary of Corvette Racing booklet. It's called Pratt Miller Engineering 2008, 10 years of Corvette Racing, and it's available on the internet. If you just go to prattmiller.com or Google Pratt and Miller or Pratt Miller, you should be able to find it. It's a PDF format. I downloaded it on my computer as well as I have a hard copy from Pratt Miller. But you certainly can get the PDF copy and be able to read it on your computer screen. And it really chronicles the 10 years of Pratt Miller working with Chevrolet to produce the C5R and then the C6R and race in the American Le Mans Series as well as at Le Mans 24-hour itself. Let's just open it to questions so we can get a connection with what you guys really want to talk about to do with racing. There's a gentleman back there.
What happened to those Geneva cars? I know they're 89s, and 89s never made it to the public. Did some of those vehicles destroyed or retained by GM in some way?
Chevrolet ultimately made the decision not to build and sell 89s, primarily because the instrument panel with all of its computers and the airbags changed dramatically between 89 and 90. 90 was an airbag car by requirement, FMVSS requirement. So that delayed the production introduction, and we had quite a few 89s built. The ones that were in Europe a lot of them stayed there and were used by Bosch and other suppliers as test cars. I don't know really what happened to them. They kind of get lost in the fog of history.
A lot of them got mashed with a bucket. The one that Keith has actually resurrected from a Lotus junkyard. And they took a front end loader
Sure.
bucket and just squashed it.
Yeah, the comment is, and these were not the cars that we drove at from Geneva to Carcassonne and then used with the press. They were a group of cars that were dedicated to Lotus test and development activities. The earliest ones were narrow-bodied Corvettes, and then they probably had some wide-bodied Corvettes later on. And the cars they had got scrapped, and they had a pike literally put through them. But a few of those have actually been found and resurrected from junkyards and are prized collector cars. Another question. There was another question here in the middle, someplace. Yes?
This doesn't actually have to do with racing. Could you talk a moment about the other part, the sequel to the France of the original unveiling of the ZR-1 at Selfridge Air Force Base in Mount Clemens, Michigan, the American version?
Are you talking about the press show that we had out at Selfridge Air Force Base?
Yeah, with the F-16s.
Yeah.
That was pretty neat.
Yeah, I think it was an SAE program, wasn't it? Yeah, and I participated, Roy Mitchell participated, and Selfridge Air Force Base is just north of Detroit off of Lake St. Clair, and I'm not even sure if Selfridge is an active base anymore, but it was active at the time. It is still active, okay.
The fighters up after the guys that hit the 9/11 towers.
Oh, okay. Yeah. They had just received their F-16s, the single-engined military fighters, and we had a display of the ZR-1 Corvettes and the engines and the cutaway stuff intermingled with F-16s, that was pretty interesting. Yeah. Yes, question.
Can you please comment on the aerodynamics of the ZR-1 body and the weight transfer from front to rear at very high speeds, say over 180?
Can I comment?
Either compared to the early C4s or anything else like that?
You know, I'm not even aware that we ran a lot of, I don't think there was any wind tunnel testing done on that configuration. So I can't compare, I can't comment usefully.
Dave?
Yeah.
Jingles can answer that question. He was answering earlier today.
Oh, okay. Jim?
All I can tell you is what it's like to drive, man.
Yeah, he can tell you what it's like to drive.
There was a real recent test where they showed the aerodynamics of the C4, C5, and C6 posted on Corvette form, both with the headlights down and the headlights up. And it was really interesting to see the different drag coefficients. And they also measured front and rear lift of all three generations. And I don't know where the data was gathered, but the charts were posted. And it was pretty fascinating to see that, you know, the C4 was not quite as aerodynamic in some areas, but had less lift in others. So there's a lot of folks that think the ZR-1, the super high speed stability is just a bit better.
I could have made those measurements, but I was never requested to, and I don't know anybody that was.
Yeah, I'm not aware of them either. Yeah, I wonder where they put all that together.
Don't know, it's
Literally, you either have to have a scale model tunnel and then you build a scale model car and put it in there, and your results are, yeah, that's what the scale model car does. Or you've got to have a full-scale tunnel, and full-scale tunnels are like a couple $1,000s an hour. And I've been to MTS when they were actually building the ground plane frame, which is a structure that's about half the size of this room. So you don't get one of those cheap. So where they got their data, I have no idea. They could also use CFD calculations, but then they need all the surfaces of the car, and they need to know that they are able to correlate what they've got. So it's to get good data is a complex engineering solution. The drag coefficient of the original 84 configuration is 0.33, 0.34, somewhere in there. And it was as low as we could get it at that time, with about 50 of those. Well, if you go to the third decimal point, let's say 0.340, call that 340. 50 of those counts is air flowing through the engine radiator cooling system. So it's a matter of developing all of those systems, and the later cars, and ultimately today with good CFD analytical capabilities, you can really fine-tune the design of the car for cooling flows, for drag, for downforce. But you go back to 84, and it was a big deal. We had to build. We did not have a wind tunnel at GM that was operational yet. We had to build scale models and then full-scale armatures and test them someplace else. I think we tested the 84 in Marietta, Georgia, at the what's now a Lockheed tunnel. Another question?
Could you talk more about the between 84 and say 87, specifically the 86, 87 racing?
Sure. We never raced the 84. John Greenwood did some racing with an 84, and had some problems with it, but he never really connected with us on what he was doing. Otherwise, I think we would have helped him resolve his problems. There was a venue that developed for the 85 Corvette in racing, and it was showroom stock racing, managed by SCCA, and they created a class for the Corvette for Porsche 944, and I think there was a Mazda in there, but or a Nissan, and yeah, Mazda RX-7 was in there at some point. Under Doug Robinson, we took on a program to develop the 85 with a couple of the potential competitors. So we had Dick Gullstrand and Jim Cook and Tommy Morrison initially working together, taking the car, putting it into a racing configuration with us, and then running practice races upwards of 24 hours. So by the time we got to the first race, first real race, we had a pretty good idea of what it took to manage the car on a racetrack, to make it capable of indeed running a 24-hour race. And we continued to support the major competitors who were running the Corvette, support them with test sessions so that they got better and better. So as Porsche got better and better, we got better and better. And with one race that I'll tell you about as an exception, the Corvettes were consistent winners for those 3 years, 85, 86, and 87 in the SCCA Showroom Stock Series mostly against Porsche. The other guys were essentially non-competitors. But Porsche ultimately got serious about it. They bought I think it was an 86 Corvette, took it over to Germany and tested it on their test track. Of course, that was a production car. The race car was close to the production car. I'm not sure what went through the minds of SCCA, but they ultimately kicked us out because the competitors were whining about our winning all the time. and the competitors in the lower performance classes, which were on the track at the same time with us, the sedans, they did not enjoy being passed aggressively by Corvettes and Porsches. They wanted to just go off and do their own little sedan racing thing. And so in the end, Corvettes and Porsches were both gone from that series. But I think it was actually it was the demise of the series that we were the only ones that were keeping the darn thing alive. Another question? Yes?
So we've seen how Pratt Miller has been able to help develop the C6, mainly in the 7-liter block, and get it implemented in production. Did you ever put
8 liter. 8.2 actually.
Well, for the C6 RS, but I'm talking about for the actual race car, the C6.
Okay, the race car is limited by rules, yes.
So did you ever try to push GM to allow you to start doing more racing with the LT5?
Well, the LT5, that's an interesting question. By the time the LT5 came along, we did not have a venue. And the venue that was available, I'm trying to think of the name of it, but you guys probably know. The series was being managed around using weight to control the relative performance of the cars. So the ZR-1 did not have a natural opportunity to perform. It got a huge weight penalty thrown at it, and that really didn't help. That's one of the things that if I had the opportunity here, I wanted to chat about a little bit, and that is the 3 years that we ran in showroom stock racing were unique in that you raced basically what you had in production, and if you had any variation from that, you shared it with SCCA with their agreement to run that variation, and you also had to commit that variation, whatever it was about to go into production. So it was an opportunity for us to move the production car ahead very rapidly in response to what we had learned, what we were learning on the racetrack. There was no weight penalty or suck through a limited induction hole applied to us. It was basically you run the production car. But most other series you're racing with some sort of intake restrictor. You may be racing with a weight penalty. And I must say that is Warren Mosler's problem today with his MT900, a very capable mid-engine production car that in its race form beats everything it comes up against. And it's basically running in GT3, I think it is. And the only way the competitors can stay with it is to get it banned, or to force huge weight penalties on the car, which is nonsense. Because a car like that, any production-based car, you really want to see it in its natural capability, not with some bone anchor tied to it. Yes. Comments on the Challenge series. Yeah, it was a fun series. Very different from the showroom stock endurance in that all the races were very short 1-hour sprint races. They were in identically prepared Corvettes that had sealed motors that were all as close to one another in performance as one could put together. And it was a real bash 'em up kind of series. It was fun to watch. And it was made for television. By then, I don't think we really learned much from it anymore because we had already developed the car as an endurance car with the competitors in the showroom stock series. Graham's here. No, that's fine. Fell in a black hole someplace.
I didn't know what time we were in.
Well, okay. You finally made it. Was that a hand at the back, or were you scratching?
Question, any comments on the World Challenge following that?
Yeah, that's what I was trying to think of, the World Challenge. We ran the ZR-1, our competitors ran the ZR-1 in that. And that's where we had to carry I don't remember what the numbers ended up as, but we carried a big weight penalty. So brakes and acceleration, everything gets dragged down by adding inappropriate weight to the car. I think it's a crummy deal for the manufacturer. Yes, over here.
Now, whatever happened with the 3-piston calipers that y'all were developing in the World Challenge?
I couldn't tell you. Question, what happened to the 3-piston calipers? And the answer is, I have no idea. If anybody else knows, speak up. But
Do you remember the name of those brakes?
do I remember the name? No, I don't. I mean, everybody is using Brembos or something like that today as a nameplate brake. In fact, brakes have changed dramatically since back in those days with the ceramic rotors pads available today for production-based cars, as well as if you got infinite money, you can run carbon-carbon. Anybody got a question for Graham? Because there was a lot of development done on the LT5 engine subsequent to all the production stuff. I don't know how close those engines were in the World Challenge. How close were they to production engines? You don't know? Okay.
In the World Challenge, they were really quite close to production engines. There was some different cam, but mainly the cams that were used back then were cams that Lotus had actually began to develop initially for the '93 engine, and until we decided we'd switch back to the stock cams or the previous year's cams. So there were some race profiles that were developed for Mercury Marine, and they really weren't that different. It was double Bs instead of an AB, so a 250, instead of having a 252 on the A, it would have a 272. There were some RB profiles that were in the 282 ranges, and there were some bigger cams than that were being developed for the 95 model year before it went out. So in terms of how close were they to production engines, they were really quite close. The latest stuff that Pratt Racing did, that was a bit more radical because you were allowed to do port work, and there was no, it was kind of funny because it was a 350, but they would let us have half an inch cam lift. So, no, thank you very much. So, you could do something pretty significant with those engines over and above the things that Morrison campaigned or the things that Kim Baker campaigned.
Can you talk a little bit about the LT5 and some of the experimental that's in the twin turbo that's in the SERV, and talk about that project a little bit?
Yeah, the SERV, it was a concept car. It was equipped with active suspension. It had a 3-speed transmission with a 2-speed overdrive unit in front of that. It was transversely mounted. We were targeting around 750 horse. In the early days, that was with a phase, I think it was a phase 2 that program started with. And the car was a radical concept, and it was absolutely an amazing thing to drive. Once we got the bugs ironed out of it, I think it cost well over $1 million to make that one car. The engine, once again, really wasn't that much different. It was lower compression. Because it was an earlier engine, it had a lot of the issues that earlier engines had. I think there's a phase 3 with one on it now. But the beauty of it was it's pressure charged, it's low compression, so you don't need to rev it anymore. It was the same 350 cubic inches. It was transversely mounted on the end of a carbon fiber torque tube. then I think the drive actually went through the oil pan on that engine. So it was part of the early development phase of the engine when we couldn't run above 4,000 RPM and things like that. You know, but obviously it got later engines as it went along. But it was relatively undramatic in terms of pressure charge in that engine. With the issues that I found later on when we were doing turbocharged engines, and actually the Lotus cars that raced against the Corvettes in the World Challenge, you know, we found some things inherent in the design that we needed to modify because we're trying to run higher levels of boost. You know, I know the race series was, if your production boost is this, that's all you could go. Well, actually, when we were racing, we found ways of avoiding the measurement device seeing. No, there's no such thing as cheating unless you get caught. So what we actually did.
That's an axiom of racing, by the way.
So what we actually did was there was an area of the plenum chamber that was an EGR tube that went across, and we actually put the monitoring device in there, and there was a solenoid for the EGR. So on the warm-up lap, the driver would drive it, and he would achieve 15 pounds of boost. And it didn't say when it had done it. All it would do was record the maximum boost that it saw. So then we switch on the heated rear screen, and it closes off that area of the plenum. So now we can run 20 pounds of boost. And it was really kind of funny because we were racing against 3.3 litre Porsches, and the Esprit would out-drag them on the straight with a 2.2 litre four-cylinder. And they complained, and then they brought the 3.6 out, and we could still out-drag them. So no one ever found that out that we'd done that. They actually got a turbo ban because we didn't homologate the TB04 housing. It took us about 5 races to get it back. But you know, but once you start running those high levels of boost, you know, the architecture of the engine needs to change at the top in terms of, you know, trying to withstand the pressures that you're now generating. And obviously, you know, a lot of the LT5 engine work was done at the racetrack, you know, and Jim Miniker and Scott Allman driving the cars, and Tommy Morrison and Baker, you know, doing lots and lots of oil surge development, ensuring that the car could actually function, or the engine could function at the limits of handling of the car. So there was a lot of development that went into the base engine that made it go so well on the racetrack. And I think that's true of the whole Corvette.
Yeah, we're in the middle back here.
Graham, could you review just briefly the various phases of the engine development? You know, what made you go from phase 1 to phase 2, and what problems you solved?
Okay, well, phase 1, as I think I joked about earlier, phase 1 engines had problems because they were iron crank. Initially, we tried a completely aluminium ladder frame, no iron inserts, and oil control was a major problem. You know, as soon as we used to have the mop and bucket award for the LT5 team, you know, who oiled down the dyno cell the worst? Yeah, and there would be several in a week, you know, and we actually had an award for that at Lotus, and it would pump the oil out. That was a major problem. So then we have to find more crankcase volume. So the phase 2s, we actually put a plate across the back of the engine and utilized some of the area at the back of the engine. And the phase 2s had the first of the iron inserts, because you would actually take an LT5 and run it for 50 hours on the dyno, and you could take the crank out without unbolting anything, basically. I mean, it was, the upper bearing webs would crack and things like that. Then we moved to the phase 3s. The phase 3s actually incorporated the breather box in the V to get us more crankcase volume. And obviously, still had the forged crank. We had some issues with piston pin hammer, where the pin would actually hammer its way out of the side of the piston. And actually, we discovered that in a bar one afternoon.
What else did you store in the bottles?
If you actually look at some of the design notes, and I wish Terry Stinson was here, because you could actually, we would go to this restaurant called Garfield's in Stillwater, Oklahoma, and they would have paper down and crayons for the kids to draw, and they would sometimes put that on the wall. We would be there going, well, what if we did this? We'd rip this paper tablecloth and take it back to work and say, all right, we need to make this, guys. But actually, it was a Saturday afternoon, and we had a problem where we'd been working with Marla, and we'd done several different iterations of the piston pin and the clip, the wire clip that holds it in, and nothing worked. One of the tests is 50 hours wide open throttle at peak power, and that's piston marking, and it sure does mark a piston. Basically it tells you, you look at it and you can see if the skirt profile's right, if the cam and the barrel on the skirt is where you need it to be. So we couldn't do 5 hours. It would just fail. Marla were insistent that it was pin hammer, and we tried different variations of end clearance and radiuses and all this sort of stuff. And myself and John Bergmeyer, one Saturday, we went into work on a Saturday morning, and we went to the local bar, which was called the Bird in Hand, at lunchtime, just to have a Pepsi and get some lunch. Yeah, and then it was kind of like Pepsi. It was black and had a white head on it. I think some people call it Guinness. But, so we were sitting there and we were talking about it, and Bergmeyer's like, what do you think? And I'm like, I don't know, man. I cannot see that it's, the pin being hammered out. What I think it is that it's gripping the wire circlip, and they've got sharp ends on them, and it's machining its way out. And Marla had said, absolutely no way can that happen, There's so much tension, and the engine's only going this fast. And so we went back into work and got a set of pistons and drilled in the pin bore area and knocked a hard pin in there so the wire clip couldn't turn around. And we didn't tell anybody, and went back the next week and said, build that engine, put it on, did 50 hours of piston marking, no problem whatsoever. So, and I think there's a time when you're that much in the trenches, and the old saying is you can't see the wood for the trees. You actually need to stop thinking about it to be able to find the solution. And there were lots of opportunities to stop thinking about it through the program.
Way back, the yellow hat.
Were there any other thoughts of using that LT5 as a boat racing engine?
We did, Mercury did build the wet vet. I don't know if it would have ever been a boat racing engine. I mean, the characteristics of the LT5, it didn't make a lot of low down torque. So getting the boat up on plane with a big boat was kind of difficult. We had interesting cooling issues because the vehicle cooling system is very well developed. The boat cooling system is kind of different, in terms of that we ended up having to go back to emulate the vehicle cooling system to stop the boat motor failing. So, and it was things like there's a phenomenon called, this is going to get boring, but I'm an engineer, sorry. There's a phenomenon called nuclear boiling, where you use the properties of boiling the water to get the heat away from the cylinder liner. Well, the problem is, if it ever becomes stagnant, then it's got superheated steam, and basically that implodes, and it will go through the metal. It'll just go and pick at the metal, and we had problems with that in the boat, and we had to go exactly back to the car's setup in terms of pressures and flows.
You had mentioned camshafts that were considered for the 93 engine. You went kind of quick on it. Could you elaborate a little bit about the different variations?
Yeah, basically, when the 93 engine was going to be designed, we had a power target. The initial concept was let's keep the A profile the same, and then make a bigger B profile.
So now the A profile is the style profile on the primary hull, right?
Yeah. and make a bigger B profile, which is a great idea. The only problem is when you run it, it makes less torque. And even though we met the power target, we were low down, probably 25 to 30 foot-pounds of torque less than the LT5, which was never considered to be as good as the L98 in terms of, you know, getting off for 1,000 RPM. So we decided that was unacceptable. So that's when we went back to do the port modifications,
Did you ever do anything with the exhaust cams?
moved it from 114 to 110. Never changed the exhaust in terms of duration or lift. For the 93 development. Obviously for race stuff we did.
Right. Red shirt. Yeah, go ahead.
Graham, I'm just curious, the oil cooler that's in the ZR-1 is basically a boat anchor. When does, the thermostat opens at what, 195 degrees Fahrenheit?
Oh, you mean the wax stack pellet in the...
Yeah.
Yeah, probably something like that, but it's got a permanent leak.
Oh, it does?
Yeah, it has to have. We found out, we went testing in Alaska with the thermostat that didn't have a permanent leak. Oh, it's amazing how fast the oil pressure goes down when that opens, because you try and push that slug that's in the cooler all the way through and it doesn't go.
So the oil is always moving through the cooler?
Yeah, there is a permanent leak through the cooler, yeah.
Leak is probably also.
What kind of volume goes through the oil cooler?
A controlled flow through the cooler. And how much it is, I couldn't tell you.
Go ahead.
Yes, Graham. I race big bore crotch rockets at over 200 miles per hour, GSXRs in particular, and all the way from '86. I don't know if you're familiar with that legendary motorcycle, all the way to the current GSXR 1000s, and there's been many generations. Suzuki is constantly refining that design, and you can actually see the DNA in the original '86 motor, four-valve combustion chamber, to the brand new one. It's all been condensed down, lightened up, stronger, more power, higher RPMs. They never let up on it. They just keep driving forward. You know, it just saddened me so much that the LT5 has so much more potential, you know, and when Dave broke the mold and brought that there to Chevrolet, that was huge. And I'm like one of the best cheerleaders. Almost every year I go to the tech center for Employees Day. I get in because I have a buddy that actually worked right with Bill Mitchell in styling. He actually did the Indy interior and stuff like that. And I'm over there showing my car all the time to the engineers and trying to get them to wrap their heads around it. And they just don't seem to get to the point. You know, and I ask them, I say, do you know anything about high-performance motorcycle designs? Do you look at some of this stuff? No, we don't want to look at that. You know, that's nothing to do with cars. But I'm just saying, I believe that if that would have continued, that program, all the way till today, let's say we had the 6th or 8th generation, all condensed down, I truly believe that we leave at least an 800 horsepower normally aspirated Corvette on the streets. I believe. What do you think?
I think conceptually, yeah, they could be. I think a lot of it is about, though, it's not necessarily just, you know, everybody says, oh, it must have been terrible with the not invented here stuff, and you're kind of surprised at how much the engineers at GM actually embraced the LT5 and also helped the LT5 program. You know, because don't forget, Lotus is Lotus. You know, we make small engines, we make them high power and whatever. You know, the compact size is kind of the efficiency thing that we do or whatever. But could the LT5 be there? Yeah. Would it be a fundamentally different character Corvette? Yes. Does the Corvette need to go that way? Right now, no. As Fred alluded to earlier, in terms of that process has been carried through in terms of the LS1s, you know, fundamental changes, and then iterating on that design to now get phenomenal performance. Would it be great to have a 4-cam Corvette? I'd like to see one. Am I the significant purchaser of a Corvette that would really make it sell in large volumes? No. So it would be a really neat engineering exercise, and I'm pretty sure we could make 800 horsepower naturally aspirated. But what is, you've got to ask yourself, what's the marketplace for Corvette? And actually I believe that, you know, Chevrolet and the Corvette platform understand pretty well what is the marketplace for Corvette, because they still make them.
We're at a very dangerous point in time here. General Motors has made a pact with the devil. You know, General Motors is no longer General Motors, it's Government Motors. And you know, the government has thrown out the CEO of General Motors and had him replaced. The government objectives are not necessarily your objectives and my objectives. You know, how will the Corvette fare through all this? The current CEO has said it'll do just fine. That's Fritz Henderson talking. If Fritz is about to take GM, probably take GM through bankruptcy. The stock price, if you go back less than 10 years, was $95 a share, and now it's like $1. I mean, we could take up a collection in this room of just the change in our pockets and buy General Motors, literally. So it is a very dangerous time for the Corvette, given that the government objectives are not necessarily your or mine or, you know, Corvette enthusiast objectives. Now, there is talk that Roger Penske is hovering over all this, looking to buy on the cheap, I'm sure, pieces of General Motors that are being thrown away, like Saturn. And Peter DeLorenzo, who writes Auto Extremist as an online blog, has commented, Roger, don't forget the Corvette. And that would, in my mind, or my estimation, be a true renaissance for the Corvette to get it into the hands of somebody like Roger Penske, who will see to it that the car develops its performance character as well as on all other fronts. Roger's, he's an incredible individual. I'm sure you're aware of his continual involvement with Indy racing, and he was involved with the Camaro racing back in the late 60s. So it's a dangerous time. I have no idea what's going to happen. Anybody that says they do is either got a big pile of money and ready to buy something, or they're just talking. So we'll just, the rest of us just have to wait for a while and see where all this comes out. And is there an 800 horsepower Corvette? Hell, there's a 638 horsepower Corvette, so that's pretty conservative.
But it's got the gas guzzler tax attached to it.
Oh, yes, it's got a gas guzzler.
Never had that happen with your special.
Well, I understand. But there's some point where it's unavoidable, apparently. I don't know. The emission requirements today are more severe than they were 10, 15 years ago. Nothing gets easier, and it's a matter of putting all these technologies together as best one can. And I'm sure they'll work their way out of the gas guzzler if they can. But yeah, that certainly is a drag on that engine. Yeah, over here.
I work at DOT, and it's kind of the heart of the lunatic rules that the government's trying to impose on all the manufacturers, and they basically are starting to legislate people out of business because they don't know any better. And
You mean DOT doesn't know any better?
the government in general.
Okay,
Now that
yeah.
you have the government trying to manage a business that they don't understand, they're looking at other factors rather than sports cars, that's for sure. Their primary focus is safety and emissions and carbon footprint and all of those types of things that they look to pin on the auto manufacturers in terms of goals. And typically, the engineers have always been able to rescue it through technology. But you start to see a shift towards a much more radical way of thinking, getting away from internal combustion. And you know, I'd like to hear what you guys think about the future of things like electric propulsion and turbines and things like that. It would be a very radical shift. Can we ever see a day where that becomes cost effective to the point where the new Corvette, we won't be talking about 4 valves, we'll be talking about electrically actuated valves or electric Corvettes or things of that nature.
Did everybody hear the comment and question? Can you hear it back? You can? Because I can't hear you. I think I see some heads nodding. Yeah. You know, it's got to be tough for you to work in a place like DOT and see all that going on and be an enthusiast at the same time.
I used to run the DOT dockets, which was the rulemaking repository. So when you quoted the federal highways, you know, that rule has existed from the dawn of time.
Well, not exactly the dawn of time, but
96.
yeah, that's not the dawn of time.
Yeah, in my career there it was.
Okay, okay. Well, I'm older than you are, I guess.